Let's talk about finding the factorial of a number. I'm sure you've probably heard of this in your math classes or CS classes, but just as a refresher, and for those of you who haven't heard of this problem yet, what factorial says is that given a number n, we want to find n times n minus 1 times n minus 2 times dot 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 all the way down to 1. And this is usually denoted n followed by an exclamation point. This represents a factorial. So just as an example, 3 factorial would be equal to 3 times 2 times 1, and that would be 6. Likewise, 4 factorial would be 4 times 3 times 2 times 1, which is 2 times 3, which is 6, 6 times 4, which is 24, and just to drive the point home, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 2 times 3, which is 6, 6 times 4, which is 24, and 24 times 5, which is 120. I think some of you might be noticing what's going on here. What if I said, all right, let's continue this pattern and calculate 6 factorial. All right, what is 6 factorial? And I would write out the definition again. 6 times 5 times 4 times 3 times 2 times 1. And I would go ahead and multiply these numbers together. But I think one thing you guys might be noticing is that if I started doing 2 times 3 times 4 times 5, well, we've already solved this problem here. In fact, it would be pretty wasteful for me to go ahead and calculate this from scratch again when we've already solved this problem right here. Right? This problem I've boxed in we've already figured it out. So what I can say is that 6 factorial is instead 6 times 5 factorial. And we've already figured out what 5 factorial is, right? So it's 6 times 120, which comes out to be 720. All right. Well, why don't we move this number n to a larger number? Let's say, let me start a new section, switch colors. Let's say I wanted to know what is 500 factorial. Right, and so what one could do is just plug in the definition of factorial and say that, all right, 500 factorial is just 500 times 499 times 498 times 497 times 496 all the way down to 1. And so what we find out, like if we were actually to like calculate those multiplications, calculate them, like put them in our calculator and calculate them straight up, well, we find that 500 factorial is really hard to find. Right? It's a really big number. It'd be a really long and tedious effort. But what if I told you that you were given 499 factorial? Let's say you knew this number, right? Let's say you knew the answer to 499 factorial. Well, you could apply the same observation that we made up here, which is that if we were finding 6 factorial, then if we knew 5 factorial, all we had to do was just multiply that 5 factorial by 6. So we could apply that same observation here and say that even though 500 factorial is really hard to find, even though 500 factorial is hard, if we were somehow given 499 factorial, then 500 factorial now becomes easy. Right? And it becomes easy in the sense that we would just calculate 500 times 499 factorial equals our desired outcome. So this observation here, that if we had a really large input that was really hard to find, but if we were given somehow the answer to the same problem, right, we were still doing the same problem here, which is factorial. If we were somehow given the answer to the same problem of a smaller input size, then all of a sudden solving our original problem now becomes a lot easier. And this pattern here is the basis of recursion, right? Which is a pretty widely used concept in CS and certainly in your undergraduate career. So what recursion says is that let's say you start off, so you have a problem on an input, right? We have some problem that we want to solve on a given input. So our first step would be to make the input smaller. And then our second step would be to solve the problem on the smaller input. And then our third step would be to use whatever we found here, the answer to this, to use that to solve the original problem. And so if we were to